Thank you for attending this presentation. My name is Andrés Baloyan, and I will introduce our method for building a scalable attribute extractor. Our motivation is that many fashion products from e-commerce are not described well enough, commonly lacking information about color and texture, among others. This affects search engines that are based on product labels, often leading to incomplete search results and thus losing potential sales. Training a convolutional classifier with a fixed number of classes may work in some cases, but that approach does not scale for real applications where the number of attributes can grow frequently. Our idea is to leverage the capability of hidden layers of convolutional networks trained on large datasets like ImageNet to extract various specific visual attributes. We take advantage of this capability in order to produce a classifier that can dynamically support new classes. To add a new class, instead of having to retrain the network, only a few examples of each new class are needed to form a pre-labeled set. Before building the classifier, we first identify the blocks of the network that best discriminate the attribute type we are interested in extracting. Then, we use the output of these blocks to select the predominant class among the closest activations of the pre-labeled set. In this example, we identify that block 4 best captures texture information as depicted by clustering metrics and UMAP visualization. Using our method with a ResNet 50 model trained on ImageNet, we achieved an attribute accuracy of over 93% for both colors and textures. We also observed that by reducing the original feature space to 8 dimensions with UMAP, we could achieve an accuracy of 91% for color and 93% for texture, showing the potential of our method to work in low dimensions. To sum up, our main contribution is a method to build scalable attribute extractors that do not need to be retrained every time we want to add a new class. Thank you again and see you at the poster session.